A block of mass 2 kilograms rests on a rough horizontal table with a coefficient of friction 0.4. It is attached by a light inextensible string to a particle 6 kilograms. The string passes over a small pulley at the edge of the table and the mass 6 kilograms hangs freely. Find the acceleration of the system, the tension of the string and the resultant force acting on the pulley. So what we've got here is a system, these are attached by a string. This is obviously going to move in this direction and therefore this is going to move in this direction. So first of all what we've got to do is find the value of this F here, which is the friction between this block and the table. So resolving vertically, we have R, the reaction, minus 2G is equal to 0, which is going to give that R is equal to 2G newtons. When the system starts to move, the frictional force will be equal to mu times R, its maximum. So that will be equal to 0.4 times R, which is 0.4. Now my value of R is 2G, so it's going to be 0.4 times 2G, which gives 2 times 0.4, which is 0.8 times G. Right, when the system starts to move with an acceleration of a meters per second squared, for the 2 kilogram mass, this one here, it will be T minus F. T minus F will be equal to MA, which is 2 times A, which will be T minus 0.8 G, because we just calculated F to be 0.8 G, is equal to 2A. So that's going to be my first equation. For the 6 kilogram mass, it was going to be 6G minus the tension is going to be equal to MA, which is going to be 6 times A. What we've got to do is solve these two equations. It's easily solved by doing 1 plus 2. So if you do 1 plus 2, the t's will cancel out, and you'll get 6G minus 0.8G is equal to 2A plus 6A, which makes 8A. Therefore, A will be equal to 6G minus 0.8G, which is 5.2G, divided by 8. G is equal to 9.8 meters per second squared, and therefore A will be equal to 6.37 meters per second squared. Now, to find T, you just need to substitute back into one of the original equations. So we're going to substitute back into 1. So we're going to have T minus 0.8G is equal to 2 times A, so it's 2 times 6.37. So T will be equal to 12.47 plus 0.8G. Sorry, just to correct myself, T will be equal to 12.74 plus 0.8G, which when we work that out, G being 9.8 will give me 20.58 newtons. Now we're asked to find the force on the pulley. The pulley's here. Force on the pulley, which is here. So if we just consider this is 20.58 newtons, this is 20.58 newtons. To find the force on the pulley, the string will exert a force of 20.58 in that direction and 20.58 in that direction, and this will be the resultant of those two forces. So to find the resultant, we have to use Pythagoras Theorem. I'm making a right angle triangle, so it's going to be the square root of 20.58 squared plus 20.58 squared, which is going to give me 29.104, which is 29.1 newtons. And then this force, the resultant force, will act at 45 degrees to the horizontal. This angle here will be 45 degrees.